TW cable is not an appropriate substitute for THHN cable in 15 or 20 amps branch circuits, specifically within a dwelling. The suitability of electrical cables for specific applications depends significantly on their insulation type, ampacity, and compliance with the National Electrical Code, commonly referred to as the NEC. Understanding these factors is crucial for ensuring electrical safety and preventing hazards like overheating, insulation failure, and fire. Let's delve into why TW cable is not a suitable replacement for THHN cable in these scenarios. Firstly, consider the insulation type. TW cable, where the letters TW stand for thermoplastic water resistant, is an older type of wiring with a low temperature rating compared to THHN cable. THHN, which stands for thermoplastic high heat resistant nylon coated, offers better heat resistance and overall durability. This difference in insulation directly impacts the ampacity, which is the current carrying capacity of the cable. The NEC specifies ampacity ratings based on insulation type and conductor size. For instance, a #12 American wire gauge or AUG copper conductor with TW insulation typically has a lower ampacity rating than a #12 AWG copper conductor with THHN insulation. Secondly, examine the ampacity requirements for 15 and 20 amps branch circuits. In residential wiring, branch circuits are commonly rated at 15 or 20 amps to supply power to lighting, receptacles, and small appliances. The NEC mandates that the conductors used in these circuits must have an ampacity equal to or greater than the circuit's overcurrent protection, such as the circuit breaker or fuse. For a 15 amp circuit, the conductor must be rated for at least 15 amps, and for a 20 amp circuit, it must be rated for at least 20 amps. Now let's compare the ampacity ratings of TW and THHN cables. While the exact ampacity values depend on specific installation conditions such as ambient temperature and the number of conductors bundled together, THHN cable generally has a higher ampacity rating than TW cable for the same conductor size. For example, under typical installation conditions, a #12 AWG copper conductor with THHN insulation might be rated for 25 or 30 amps, whereas a #12 AWG copper conductor with TW insulation might be rated lower, potentially at only 20 amps. This difference in ampacity is significant because using TW cable in a 20 amp circuit could lead to overheating of the conductor, as it would be operating at or near its maximum capacity. Overheating can degrade the insulation, increasing the risk of short circuits and fires. Thirdly, think about the NEC compliance. The NEC is a widely adopted standard for safe electrical installations. It provides detailed guidelines for selecting and installing electrical cables, considering factors such as insulation type, ampacity, and application. When replacing existing wiring, it is crucial to ensure that the new wiring meets or exceeds the requirements of the NEC. Using TW cable in place of THHN cable in a 15 or 20 amps branch circuit might violate the NEC, especially if the TW cable's ampacity is insufficient for the circuit's rating. Furthermore, the NEC specifies acceptable wiring methods for different types of occupancies, including dwellings. These methods often include requirements for cable type, protection, and installation practices. Using an inappropriate cable type like TW cable in a situation where THHN is required could result in non-compliance with local electrical codes and regulations. Considering practical implications, replacing THHN cable with TW cable could have several negative consequences. The reduced ampacity of TW cable increases the risk of overheating, potentially leading to insulation breakdown and electrical hazards. This is especially concerning in residential settings where electrical systems are often subjected to heavy use and varying load conditions. Additionally, using TW cable might void insurance coverage in the event of an electrical fire or other incident. Insurance companies typically require that electrical installations comply with the NEC and local codes, and using non-compliant wiring could be grounds for denying a claim. Therefore, it is essential to always use the correct type of cable for the intended application and to consult with a qualified electrician if there is any uncertainty. Always prioritize safety and compliance with electrical codes to protect people and property from electrical hazards. Here is a review of key considerations. Firstly, insulation type matters. TW cable has lower heat resistance compared to THHN cable. Secondly, ampacity is crucial. THHN generally has a higher ampacity than TW for the same conductor size. Thirdly, NEC compliance is essential. Ensure wiring meets or exceeds NEC requirements. Fourthly, overheating is a risk. Using TW cable in a 20 amp circuit can cause overheating. Fifthly, safety first. Always prioritize electrical safety in compliance with codes. In summary, TW cable is not a suitable replacement for THHN cable in 15 or 20 amps branch circuits in a dwelling due to its lower temperature rating, reduced ampacity, and potential non-compliance with the NEC. It is always recommended to use the appropriate type of cable for the specific application and to consult with a qualified electrician to ensure electrical safety and compliance with local codes. Always use appropriate wiring methods for all circuits. It's imperative to select the correct wiring and cabling for all electrical work. Wiring must have sufficient ampacity to handle the circuit load. Undersized wiring can overheat, creating fire danger. Always consult the NEC for proper wire sizing. It is crucial to use correctly rated overcurrent protection. Using oversized breakers on undersized wire can cause fire. Never exceed the wire's safe ampacity. Always refer to ampacity charts in the NEC. Proper grounding is essential for electrical safety. Grounding helps protect against electrical shock. Ensure all circuits are properly grounded per the NEC. Use appropriate connectors and terminations. Poor connections can cause overheating and fires. Always tighten connections to the proper torque. Inspect wiring regularly for damage or wear. Replace damaged wiring immediately. Never ignore signs of electrical problems such as flickering lights or burning smells. Have electrical work done by a qualified electrician. Electrical work can be dangerous and should only be performed by trained professionals. Always obtain necessary permits for electrical work. Permits ensure compliance with local codes. Follow all safety precautions when working with electricity. Turn off power before working on circuits. Use insulated tools and wear appropriate personal protective equipment, also referred to as PPE. Never work on live circuits. Double-check all wiring connections. Ensure all connections are secure and properly insulated. Label all circuits clearly. Labeling makes it easier to identify circuits for maintenance or troubleshooting. Keep electrical panels accessible. Do not block access to electrical panels. Maintain a clear workspace around electrical equipment. Avoid storing flammable materials near electrical panels. Install smoke detectors and carbon monoxide detectors. These devices can provide early warning of electrical fires or carbon monoxide leaks. Develop an emergency plan in case of an electrical fire. Know how to shut off power and evacuate safely. Educate family members about electrical safety. Teach children about the dangers of electricity. Take a first aid and cardiopulmonary resuscitation, commonly referred to as CPR, course. Be prepared to respond in case of an electrical shock. Regularly test ground fault circuit interrupters, commonly referred to as GFCIs. GFCIs protect against electrical shock in wet locations. Install arc fault circuit interrupters, commonly referred to as FSIs, in bedrooms. FSIs protect against electrical fires caused by arcing faults. Use surge protectors to protect electronic equipment. Surge protectors can prevent damage from power surges. Unplug electronic equipment during thunderstorms. Lightning strikes can cause severe damage. Inspect extension cords regularly for damage. Replace damaged extension cords immediately. Do not overload extension cords. Overloading can cause overheating and fires. Use extension cords only temporarily. For permanent power, install additional outlets. Avoid running extension cords under rugs or furniture. This can damage the cords and create a fire hazard. Do not staple or nail extension cords to walls or floors. This can damage the insulation and create a shock hazard. Keep electrical equipment away from water. Water can conduct electricity and cause shock. Never use electrical appliances near bathtubs or showers. Be aware of overhead power lines. Maintain a safe distance from power lines when working outdoors. Call before you dig. Before digging, contact your local utility to locate underground utilities. Be cautious when using ladders near power lines. Use non-conductive ladders. Report any damaged or downed power lines immediately. Stay away from downed power lines. Consider energy efficiency when selecting electrical equipment. Energy-efficient appliances can save money on utility bills. Use light-emitting diode, commonly referred to as LED lighting. LED lights are more energy efficient than incandescent lights. Install timers or sensors to control lighting. Timers and sensors can save energy by turning off lights when they are not needed. Insulate electrical outlets and switches on exterior walls. Insulation can reduce energy loss. Seal air leaks around wiring penetrations. Sealing leaks can improve energy efficiency. Regularly inspect electrical systems for energy waste. Look for opportunities to save energy. Consider alternative energy sources, such as solar or wind power. Alternative energy can reduce reliance on fossil fuels. Stay informed about the latest electrical safety standards. Keep up to date with changes to the NEC and local codes. Participate in electrical safety training programs. Training can improve your knowledge and skills. Support organizations that promote electrical safety. These organizations work to prevent electrical accidents. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help protect yourself and others from electrical hazards. If ever in doubt, consult a qualified electrician. The consequences of electrical mishaps are far too dangerous to risk working on electrical systems without the knowledge or expertise of a licensed professional. Also make sure to comply with all regulations as described in the NEC handbook to avoid potential issues.